We're here in Chernobyl town as part of the Chernobyl Summer School. So we've got 20 PhD students from different universities in the UK, all studying radioactivity in the environment in the most important place in the world for that research, which is the site of the Chernobyl nuclear accident. We're teaching them about practical radioecology, so they're experiencing what it is to stand in the site of the world's worst nuclear disaster, understand the effects of that disaster, and also to get for me it's important that they get a radiation dose, only a small one. So where are we? We're down here somewhere, and this is the Ukrainian sector of the exclusion zone, and there's another half or so, slightly more in Belarus, coming up here. And this is the Belarus-Ukraine border. So Chernobyl town is there, cooling pond along here, the plant and Pripyat here, and Buryakova, where we were, is there. That's the railway line that we kept crossing along here. The red forest is this bit here. The tree project is a research project funded by the Natural Environment Research Council of the UK, and we're studying transfers of radioactivity in the environment. So we want to know if there's an accident, or for nuclear waste repositories, if radioactivity gets into the environment, we want to know where it goes. Does it transfer into foodstuffs? Does it affect the wildlife? How long will it, for example, a nuclear waste repository, if there's releases from a waste repository, how long will the radiation be in the environment, and what effect will it have on people and animals? What I'm going to ask you to do, I'm going to put you in groups again, 4 groups of 5, and I would like you to be able to get a sense of how we calculate radiation dose. So in your groups, you're going to choose maybe 3 areas here, maybe the 10 or 30 kilobecquerel per square metre area, maybe one in the middle, maybe the yellow one, and then one around the red forest where it's up to sort of 10 megabecquerels per square metre. So choose 3 areas and go through the dose calculations to work out what's the external dose, what's the internal dose, a hypothetical population of people who are living off the land here, what sort of dose would they get from the foodstuffs that they eat. And in the lecture I give later on this afternoon about radiation risk, I want you to think about what the risk of that dose to a hypothetical bunch of people living here, say here or here, would be, and decide whether that's acceptable, and think about what management options, because arguably now, this is as of 2013, arguably now you could move the zone here or somewhere. You probably wouldn't want to move, you wouldn't want to let people in here, but what are the sort of doses, what's an acceptable risk, and these are things that you can calculate. The tree project is very multidisciplinary. We've got almost every scientific discipline, from mathematics, I'm a physicist, we've got biologists, geneticists, chemists, because we're trying to look at an integrated project going through the environment, so you need modelling in that, and you need the various biological disciplines and chemistry to understand the soil chemistry, biology to understand both the uptake, the transfer of radioactivity through the ecosystem, and also the effects on the ecosystem.
Perhaps you can choose a tree at random over there, and if somebody then wants to run the tape measure along to another tree over there, just marking out a square area. You've got to note down the dimensions of the area as well. So literally you just stand there, if that's one corner of the survey area, yes, that tree. So if you want to take the tape measure and run it along to one of these trees here.
I've been working on the Chernobyl accident since 1991, so Chernobyl was in 1986, and I started studying radioactivity in the Lake District, in the English Lake District, studying the transfer of radioactive cesium, which is the the most important long-term contaminant from the Chernobyl accident, studying the transfer of radiocesium in lakes and transfer to fish within the UK, because in the UK we had some fallout from the Chernobyl accident. And in the 1990s I started working with my Ukrainian, Belarusian and Russian colleagues studying the transfer of radioactivity in aquatic environments here in the Chernobyl zone.
So as part of our trip out on this NERC summer school, we've brought the students to this radar installation. It's called Duga 3, or also known as Chernobyl 2. And this radar installation was built for use during the time of the Cold War to be able to monitor the pathway of ballistic missiles should they be fired over from America through to the Soviet Union. Obviously, since the time of the reactor, this whole area has been abandoned, so the reactor disaster created this exclusion zone. We now get to come to a radar station which has been left unadulterated and is still an absolutely amazing sight. So if we look up here, you can just see the structures heading up into the sky. And as an engineering feat, it is truly amazing. We've been really privileged over the course of this summer school to already go and see the Chernobyl nuclear power plant up close, to see the new safe confinement up close, and now to come and see Duga 3. And as I work in the Chernobyl Exclusion Zone, I often see, as I'm undertaking my field sampling work, this installation projecting up over the tree line. There are a couple of things about the Chernobyl skyline that really stand out. One is the new safe confinement facility, that Chernobyl Arch as it's known, and the other one is Duga 3. So it's really great to finally make it here and get to see what this installation looks like up close and personal.
I think there was particularly in the 1990s, there were two important factors. One that was Europe was affected, Western Europe was affected by the Chernobyl accident, and secondly, it was at the time of the collapse of the Soviet Union, so the new independent states were being formed, and there was a big impetus to begin scientific collaboration with Ukrainian, Belarusian and Russian scientists. And at the time, the European Commission spent significant money on joint research between Ukraine, Belarus, Russia and the countries of Western Europe.
It's just a copy of the top Soviet Communist Party newspaper report after Chernobyl accident. The first one say, and this was published in April the 30th of 1986, that there is just a very minor leakage of radioactivity from Unit 4 of Chernobyl nuclear power plant. This was firstly reported. Yes. What they say about it is just for the first idea of leader of Communist Party was just to hide the accident we talk it. But there were a lot of professional people who can really just with their not direct information, but just thinking about what they have in their hand, they can recover or to estimate what is the level of a real accident was. And as a result, just one day later, the Communist Party of Soviet Union just was forced to report or to realize that the scale of accident is really, really huge. And they said this was just a chain reaction taking place inside the destroyed Unit 4.
The collaboration to get the grant for the tree project was mainly institutes had worked together before, but in this area since the 1990s, so Chernobyl was 1986, there was significant funding for this research in the 1990s, but as people forgot about the Chernobyl accident, that funding tended to die down, so there was a lean point for us scientists, but we still kept the collaboration going over that time. And when we had this opportunity, we put together a group of people who'd all worked before in various ways, but never had the opportunity to have an integrated research project which could study all the aspects of radioactivity in the environment, from the transfer from soil into into plants, the transfer from plants into animals, ultimately radiation doses to humans, and also radiation effects on the ecosystem itself. This project is probably the first chance we've had really to create this interdisciplinarity, and it's quite unique in our field that we can put all these groups of scientists together to study with the same objective and learn from each other.
A Solmeter 3, which is the wildlife acoustics monitor and recorder that we're using here. No. It's got 2 omnidirectional microphones. We've got the left channel and the right channel, both of which are picking up sounds.
It's a great motivator to understand what radiation risk means. If you've stood in for example, the Red Forest where we visit today is one of the most contaminated lands in the world. We'll go there for a short period of time, we'll get a small radiation dose, we'll see what's happening there to the environment, and we'll understand what a radiation dose means to our health.
That is why Red Forest absolutely inhabited by animals, absolutely inhabited. And you can meet there both small mammals and big mammals and birds. There are several birds which breed directly on the ground. Another point, how healthy that living in the Red Forest. Absolutely another point.
So the summer school is something I've been dreaming about doing for 10 years, and this is the first opportunity I've had to do it. I think it's really important that students get first-hand experience of being in a radioactively contaminated area, understand all the aspects of radioactively contaminated land, and that's true of whatever discipline you're in. So we've got students here who are studying the mathematics of the transfer of radioactivity in a deep waste, nuclear waste repository, so the movement of radioactivity through rock. People in this area still need to understand what radiation risk means to the people living on the surface in order to get the bigger picture of what their work means, what a geological waste repository means, and what the potential impacts of that are. So far yesterday we were in visiting the Chernobyl nuclear power station. We heard from the safety director from the nuclear power station about what it meant to the people of the town right next to the power station, the town of Pripyat, which had a population of 50,000 people and was evacuated 36 hours after the accident. So we heard from him what it meant to those people, what effect the evacuation had on their lives, how the accident happened, why it happened, and what the significance of that is in the long term.
This is park in the centre of Chernobyl town, and what you have here is a list of names running back of the villages which have been abandoned within the exclusion zone as a result of the Chernobyl accident. Behind us we have this area that commemorates the villages, and you can see here a map of the zone made out of concrete with points for each of the different villages. Each one of these is a village, and on the 26th of April each year they have a memorial service here where people light candles, place them in each of these holders, so they have a candle burning for each of the villages and remember all of those villages that have been lost as a result of the accident.
Today we're going to be visiting Pripyat itself. We're going to see some of the abandoned buildings. We're going to see a part of the Pripyat River. So the Chernobyl was built next to the Pripyat River, one of the most important rivers in this region, because they used the cooling water to cool the reactors. And yesterday we saw the cooling pond, which is a 22 square kilometre reservoir which held the cooling water. So they took the cooling water in to the reactors, cooled the reactors, and then discharged warm water back into the reservoir.
So this group of Ukrainian Hydrometeorological Institute just doing their regular survey on the cooling pond, collecting water and sediment and bottom sediment. So now this is the only location at the cooling pond where you still have some relatively easy access to the water. Very soon, even here, it would be very difficult to get access to the water.
So we saw the cooling pond, and currently the cooling pond is in the process of decommissioning. So we saw what that meant and what that will mean in the future to the cooling pond area, and learnt a bit about the radiation risk that the cooling pond represents, because the sediments of the cooling pond are quite highly contaminated. So today we'll visit Pripyat and see the abandoned area and see how nature has responded to this accident. So the people moved out, and that has had significant effects on the people, so not least the social impacts of moving them from their environment, the psychological impact of the radiation risk, which indeed many radiation scientists, myself included, believe that's been the major impact of the Chernobyl accident, rather than the specific radiation health risk itself. These wider consequences of the accident are probably more important.
Now at the start of the run into Pripyat, so we've brought a coachload of about 20 PhD students and postdocs here. We're going to work our way into Pripyat, give them the opportunity to see the abandoned city of Pripyat, start to work their way around, explore some of the buildings and explore the lives of the people that were there and what's left now as a result of 30 years after the world's worst nuclear disaster turned it into an abandoned city.
What's happened to Pripyat in the nearly 30 years since it was abandoned, and we'll see trees growing in the middle of roads, in the middle of the sports field there's now a small forest. Animals are now, we probably won't see any animals today, but there's plenty of evidence that there are wild animals now coming into the zone. So when the people have moved out, nature has reclaimed the land, and I think that's a very important and fascinating lesson for the students.
Part of culture in the city of Pripyat. So this was an area that was used during the old Soviet era for people to come along and to be able to spend some time engaging with the local culture and having some recreational time from their working lives. Obviously there was a lot of communal working activity, and people were allowed to come in here to have that recreational and relaxation time.
Coming up next April will be 30 years since the Chernobyl accident, and we scientists have been studying this. I've been studying Chernobyl for more than 20 years now. We've learned an awful lot about radioactivity in the environment, but in some respects we've failed to communicate that to the general people, to the general public. And that's, in some respects, that's our fault, but in other respects it's about the difficulty of communicating radiation risk. And I think the thing that we need to do is better communicate what radiation means to individual people, because the lesson from Chernobyl is that actually, though the consequences were clearly enormous, the risk to individual people is extremely low. Even the people in Ukraine, even the people who were evacuated from Pripyat, their individual radiation risk is not nearly the most important health impact in their lives. The other things that we worry about, smoking risk, not eating properly, not exercising, these are much more significant impacts on their health than radiation. But because we failed to communicate that radiation risk to those people, the psychological and social consequences of Chernobyl have been very significant, and people overestimate the risk of radiation to their health. Now, nearly 5 years on from the Fukushima accident, Japanese scientists are finding the same thing. Somehow we need to be able to communicate radiation risk better.